Hello, students. Good to see all of you here. Can you hear me?
Yes, ma'am.
Can you hear me?
Yes, ma'am.
That's good. Okay, so everyone said yes, they have chatted. Yeah. So nice to see all of you. I'm your maths teacher. I'll be teaching you KSET short course, that is the crash course. And I think already you know about the timetable, which lesson we will be doing, which day. Everything is clearly mentioned. So we will do complex numbers today. Complex numbers and quadratic equations together, we are taking 4 days to complete because it's a very big chapter. So first, you must know some important formulae about the complex numbers. I won't write it on the board. I'll just paste it so that it will be neat and it will be a quick process also. Before going to the questions, you must be good with the formulas. The chapter's name is complex numbers. Now, what is complex number? What is the necessity of complex number? Why complex numbers we have to learn? For that, a few definitions, a few things. First, I will post it on the board. And then we will learn that. I hope this is clear. Can you all see the font? Do you want me to increase the font? Hello? Okay, so it's clear. You are able to see. Fine. So actually, the necessity for complex numbers arose because we are not able to find the square root of negative numbers, like square root of -1, square root of -2, square root of -3, square root of -4. We can't find. That's why we are learning complex numbers, because in complex numbers, square root of -1 is given as imaginary number I. I is called imaginary number. And this imaginary number will allow us to find the square root of negative numbers. Like if you want to find the square root of -2, you have to write it as square root of 2 into square root of -1. Square root of 2 into I, because square root of -1 is I, and so the answer will be I square root of 2. Similarly, square root of -3 is I square root of 3. Square root of -4 is I square root of 4, but square root of 4 is 2, so 2I. Like this, we can find square root of any negative number now. So there are some numbers which have I, there are some numbers which don't have I. The numbers which have I, like this, or like this, or like this, or like this, these are only called complex numbers, which is given here. But there is one standard form of complex numbers. Every complex number can be written as x plus iy. And you can, in short, denote by z. So if you have I, you can write it as 0 plus I. If you have I root 2, you can write as 0 plus I root 2. So that you will have x plus iy form. If you have 3, you can write it as 3 plus 0i, x plus iy form. If you have minus 7 plus 0i. Every number, every real number can be written as complex number. Rather, till now, whatever numbers you have learned, natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, every number can be written as x plus iy, complex number form. X is a real number, y is a real number. See here, x is 0, it's a real number, y is 1, it's a real number. 0 is a real number, root 2 is a real number, 3 is a real number, 0 is a real number, minus 7 is a real number, 0 is a real number. But every complex number has two parts, that is real part and imaginary part. Real part is x, imaginary part is y, which you can write like this. Real number of z is x, imaginary part of z is y. In short, instead of writing sentences like this, real part is x, imaginary part is y. Instead of writing that, in short, you can write real part of z is x, imaginary part of z is y. Whenever and wherever you have doubt, you can stop me and ask, because this is the time to clear your doubts. Later on, you won't get time to clear your doubts. So, if the complex number is purely real, this complex number is purely real. Here, these complex numbers are purely real. That is why imaginary parts are zeros. These complex numbers are purely imaginary. They are purely imaginary. That is why real parts are zeros. The next formula tells us this I is called iota. I full form is iota. And because I is square root of minus 1, I square will be square root of minus 1 into square root of minus 1, which will be square root of 1, which is 1. So, if you do like this, you are getting like this, isn't it? If you are taking I square, square root of minus 1, square root of minus 1, you are getting 1. But this is not correct. I square will not be equal to 1. What will you have? What you have to do for finding I square? I square means minus 1 power half is squared. This minus 1 square root is squared. So 2 and 2 will cancel. You will have minus 1 power. This is the correct way to find I square. So remember, if I is square root of minus 1, I square will be minus 1. And after that, higher powers also you can find. If you want to find I cube, what will be I cube? I square into I. I square is minus 1. I is same. So minus I. Then I power 4. It is I square whole square. That is I square is minus 1 whole square positive 1. That's why here it is written I cube is minus 1. I power 4 is 1. And after that, the same thing will repeat. What's the same thing going to repeat? If you have I power 5, what is I power 5? I power 4 into I. That is 1 into I. It is I. So I power 5 will be same as I. I power 6 will be same as I square. I power 7 will be same as I cube. This is I square, this is I cube. I power 8 will be same as I power 4, that is 1. So I power 5 will be I power 6 will be minus 1, I power 7 will be minus I power 8 will be, these 4 will be repeating always. Again, I power 9, I power 10, I power 11, I power 12. So remember, if the powers are multiples of 4, they will be equal to 1. I power 4, 4 2 is 8, 4 3 is 12, 4 4 is 16, 4 5 is 20. All these will be equal to 1. In short, you can remember like this. Okay, the next set of formulas I'm pasting now. It will take a little time to paste, but if I write, it will take more time. Just for explanation, I'm writing. Okay, the next one. Next is how you can say two complex numbers are equal. If Z1 complex number is given as A1 plus IB1 and Z2 complex number is given as A2 plus IB2, then if A1 and A2 are equal, B1 and B2 are equal, that is real parts are equal, imaginary parts are equal, then you can say Z1 is equal to Z2. Next is conjugate of a complex number. If this is the complex number, the conjugate Z bar, conjugate means Z bar, that is given as A minus IB. Next is modulus. If Z is the complex number, modulus of Z, it is given as square root of A square plus B square. That means square root of real part of Z whole square plus imaginary part of Z whole square. I am repeating again, whenever you feel it is difficult or you did not understand, total I am seeing how many students? Anyone. You can unmute yourself, you can stop. Don't think that because you are asking doubts, you are not a good student. Don't think like that. Those who ask doubts, they are only good students. What I believe is, if you ask doubts, you are good students. You are understanding. You must get questions. You must get doubts. You are trying to understand. Okay. The next is argument of a complex number. Argument means, in other words, angle. Don't get scared of this word. Argument is angle in a complex number. So what is the angle in complex number? You can find if you know what is cos theta, what is sin theta in a complex number. Cos theta is A by modulus of Z. Sin theta is B by modulus of Z. Or in other words, tan theta is B by A. So angle, if you want, it is tan inverse B by A. You can find angle using this formula. The angle should be between 0 and 2 pi. You can start from 0, but don't take 2 pi. Start from 0 until 2 pi. Darshu, do you want to say something? Don't write anything on the board, Darshu. If you want to say something, you can type it on chat. I will see your message and I'll ask you. So angle you can find like this, but you may have a question. How angle is related to complex number? For that, you have to take a diagram. X-axis, Y-axis. You take a point A, comma B. If you draw a perpendicular and if you join origin, this distance is A. Mala is asking what type of question they will ask in exam about this concept. Yes, we are going to the questions also, Mala. From complex numbers, we have different types of questions. Once we complete the synopsis, once we complete the formulas quickly today in today's class, we will go to problems also. We will go to questions also. I will take each and every question and I'll try to answer as many as possible. Some I'll give you as homework. Some questions I'll give you as homework. On the board itself, I will give you. So either you can, I don't know how you are going to see it later. On the board, I will paste it. Either you can take the picture of it, or maybe you will be able to access the board, be able to access the recorded class after the class. Whenever you want, you can access, I think so. Everyone mute your mics unless and until you have any question, mute it. So this is A, this is B, this distance. This we will take it as theta. And we will write the hypotenuse using Pythagoras theorem, square root of A square plus B square. Now cos theta is Venuta, can you mute your mic? Cos theta is adjacent by hypotenuse. Sin theta is opposite by hypotenuse. And tan theta is opposite by adjacent. So these three formulas help us in finding the angle theta. So angle is denoted by argument of Z or amplitude of Z, anything. You can call it as arg Z, amp Z in short. Let me paste the next set of questions. The next is De Moivre's theorem. What is De Moivre's theorem? De Moivre's theorem helps us to change the complex numbers in a different form. That is called mod amp form. Mod amp form. Every complex number Z, that is A plus IB, if it is in this form, you can write it as R into cos theta plus I sin theta. R is the modulus of complex number and theta is the amplitude of the complex number. Using modulus, and amplitude. You can write every complex number in this form. This form is called mod amp form. So once you write this in mod amp form, every complex number in mod amp form, suppose if you have cos theta plus I sin theta whole power n. Suppose if you have z power 100. Suppose if you have 1 plus I root 3 power 100. If the complex number is in this form, power 100 is a very big number. To multiply it 100 times, it will be very difficult. This some of you might have learnt in PU. De Moivre's theorem you might have learnt in PU. Some of you may not have learnt in PU. But why am I telling you about this De Moivre's theorem is it is used as shortcut method. Those who did not learn, try to understand now. It is used as shortcut method because in questions they will give you what is 1 plus I root 3 power 100. If it is power 100, it is very difficult to sit and multiply. So we will convert it into mod amp form. What is mod amp form? 2 into cos pi by 3 plus I sin pi by 3. This is the mod amp form. Now, if you take this and power 100, it is very easy to find using De Moivre's theorem. How? Whenever you have cos theta plus I sin theta power n, you can write it as cos n theta plus I sin n theta. That means 2 power 100 will be there. You can write cos 100 pi by 3 plus I sin 100 pi by 3. Instead of multiplying 100 times, this is the easy way to write the answer. Now, what is 100 pi by 3? What is 100 pi by 3? It is very easy to know. Madhumita, don't write anything on the board. If you want to find 100 pi by 3, you have to split it. Denominator is 3. How will you split it? 33 pi plus pi by 3. So that it will be 99 pi plus pi, 100 pi. This is how you will split. And then cos 33 pi plus pi by 3. Where is this 33 pi? See, 0 is here, pi is here, 2 pi is here. All odd pi's will be here. 33 pi will be here, this side. So 33 pi plus pi by 3 means in the third quadrant. You are going in the third quadrant. Third quadrant cos will be negative. Negative cos pi by 3. Negative cos 60 is negative half. So 2 power 100 minus 1 by 2. Then I. Sine also will be in the third quadrant, negative. Sine pi by 3, sine 60 is root 3 by 2. So you will have like this. Or 2 power 99 into minus 1 minus I root 3. This is how you will get the value if you multiply 100 times. So as I told you, this is the shortcut method. If you learn this, it is very simple. 100 you multiply to pi by 3, 100 you multiply to pi by 3. After that, break the angle like this and find. Bring it to small form and find the answer. Now with this only there are some formulas. If you have cos theta minus I sin theta power n, if you have plus, here it will be plus. If you have minus, here it will be minus. So cos theta plus I sin theta whole power n will be cos n theta plus I sin n theta. Cos theta minus I sin theta whole power n is cos n theta minus I sin n. The next is cos theta minus I sin theta and cos theta plus I sin theta are reciprocals to each other. What I mean is, if you have cos pi by 3 plus I sin pi by 3, you can write it as 1 by cos pi by 3 minus I sin pi by 3. Or if you have cos pi by 3 minus I sin pi by 3, you can write it as 1 by cos pi by 3 plus I sin pi by 3. All these are formulas used in shortcut method. Then if cos theta minus I sin theta will have power minus n, it will be cos n theta plus I sin n. Next is, if you want to find the square root of a plus ib, the answer will be like x plus iy form. Square root of a plus ib answer will be x plus iy. Now, how will you get x? You have to take x square minus y square as a, 2xy as b, solve and get the answers for x and y. Now, this is a long method. Why am I taking x square minus y square as a? Why am I taking 2xy as b? That's a long process. Here they have given what they gave. Think. Imagine square root of a plus ib, answer is x plus iy. Square both the sides. When you square this side, the square root will disappear. This side you have to use a square plus b square plus 2ab. Then set the real parts equal. This real part equal to this real part. This imaginary part equal to this imaginary part. This is how you will get two equations. You have to solve these two equations to get x and y. Instead of doing all these steps, directly you can go to this step, you can memorize it. And then you will know how to find the square roots. Let's go to the next set of formulas. Today, I think we will be able to learn only these formulas. I already told you what is conjugate. Now some properties. If you take z's conjugate 2 times, you will get z only. Like if z is a plus ib, conjugate of z is, the middle plus will change to minus. If you take the conjugate second time, the middle minus will change to plus again, and this you will get z again. Then z plus z bar will be giving you 2a, real part of z, 2a you will get when you add z and z bar. When you subtract z and z bar, you will get 2bi. The answer will be 2ib. 2i, an imaginary part of z. If z and z bar are equal, that means z is a purely real complex number. See, if z is 3, z bar also will be 3. Both are equal. So it is purely real. Z is purely real. And if z plus z bar is 0, that means z is purely imaginary number. Say if I take z as purely imaginary number 2i, z bar will be minus 2i. And if you add z and z bar, These two will cancel, you will get 0. So that means Z is purely imaginary. Z and Z bar, if you multiply, you will get real part A square plus imaginary part B square. If you multiply Z and Z. Z1 plus Z2 conjugate will be same as Z1 bar plus Z2 bar. Conjugate of Z1 minus Z2 is same as Z1 bar minus Z2 bar. Conjugate of Z1 into Z2 is same as Z1 bar into Z2 bar. And conjugate of Z1 by Z2 is same as Z1 bar by Z2 bar. Z power n's conjugate is same as Z bar conjugate whole power n. What I mean is, if you have Z square, you're finding the conjugate, then you can take the conjugate of Z and then square it. Both the answers will be same. Then Z1 into Z2 bar plus Z1 bar into Z2 will be equal to 2 times real part of Z1 bar into Z2, or it will be equal to 2 times real part of Z1 into Z2 bar. This, if you want, you can multiply and see. This formula, it is used in shortcut. That is, suppose if I take Z1 as 1 plus I root 3. And Z2, I will take root 3 plus I, if I take like this. What is Z1 bar? 1 minus I root 3. What is Z2 bar? Root 3 minus I. So, if I want to multiply Z1 into Z2 bar, and then Z1 bar into Z2, and if I want to add, that means I'm multiplying 1 plus I root 3 into root 3 minus I, plus I'm multiplying 1 minus I root 3 into root 3 plus I, if I want to do this multiplication. Then that will be 2 times real part of Z1 bar into Z2. So I have to multiply Z1 bar and Z2. 1 minus I root 3. 1 minus I root 3 is Z1 bar. And Z2 is root 3 plus I. I have to multiply these two. So I will get the real part. What is the real part? 1 into root 3 is root 3. Then I will have minus I square root 3. I square is minus 1. So root 3 plus root 3. That is, I'm getting 2 root 3. So real part is 2 root 3. So the answer will be 4 root 3. This is how you can use it in shortcut methods. If you want shortcut methods, you have to remember some formulas. And the formulas you can remember by taking some examples. See, for this formula, I gave you one example. And using that I did. If you want to see whether what I did is correct or wrong, you multiply this completely, and see whether you will get 4 root 3 or not. Do it in a long process. Like this, multiply and see. Who is writing on the board? Hurry, don't write on the board. The board will get disturbed. And anyone, if they want to see, they can't see the words properly. Multiply and see the long process. Root 3 minus I plus 3I, then minus I square root 3. Like that you multiply and see. Here also you multiply root 3 plus I, then minus 3I, minus I square root 3. See, minus I plus I cancels. 3I minus 3I cancels. Root 3 minus I square is minus 1. Here also I square is minus 1. Minus 2 I square root 3. I square is minus 1. Root 3, like that you will get it. Okay. Multiply and see it. Leisurely sit and multiply and see, you will get it. Okay. Let's go to the next set of formulas. What all formulas I told you, if you want to see whether they are correct or wrong, you have to multiply and see them. Like that, with modulus also, you have some formulas, not some. You have many. But if I tell you those formulas, you will get mad seeing all those, because there are many shortcut formulas out there. As long as you are good at these shortcut formulas, you will be good at complex numbers, many shortcut formulas. So quickly, I will tell a few. You can see them, which I have posted on the board. Modulus is easy, but formulas. Modulus, if you get 0, that means the complex number is 0. That means real part is 0, imaginary part is 0. Modulus of z will be same as modulus of z bar, will be same as modulus of minus z, will be same as modulus of minus z bar. Why they gave you all these formulas? Suppose if I give you z is 3 minus I. And if I ask you, find the modulus of minus z bar. So you need not waste time in finding z bar and minus z bar. Directly you can say it will be same as square root of 9 plus 1, that is square root of 10. That is how you have to learn the formulas. These formulas, as formulas, if you see, they look very ugly. They look confusing. They look very bad. But if you practice with some problem, take any complex number from your textbook. You can make your own complex number, or from your textbook, you take any complex number, apply that formula, then it will be easy to by heart the form. See, suppose this formula, z into z bar will be mod of z whole square. Suppose in question, they will give you like this. I'll change the color. If they give you z equal to 1 plus 2i, and they ask you find z into z bar. So you need not write z bar. You need not multiply z and z bar. Directly you take the mod 1 plus 4 and square it. That means no root. 5 will be the answer. See how it became easy? The shortcut methods will be interesting if you use them. You are taking the mod of z. What I did here, I took the mod of z and I have squared it. See, mod of z is squared. Suppose this formula, mod of z1, z2. It is mod of z1 into mod of z2. So this formula is also useful. It is a shortcut method. Like if I give you z1 is equal to 1 plus 3i and z2 equal to 1 minus 2i. And if I ask you, multiply z1 and z2 and find the mod. Then what easy method you can do? Take the mod of z1, square root of 1 plus 9. Multiply with mod of z2, square root of 1 plus 4. Square root of 10 and square root of 5. Multiply. Square root of 50 will be the answer. How easy it is? Like that. The next formula. Mod of z1 by z1 by z2 is mod of z1 by mod of z2. There is printing mistake. Mod of z1 by mod of z2. Like this. Take one example and practice all the formulas. Only some important formulas, some interesting formulas I am underlining, I am highlighting. Remaining also you can find out. Suppose this formula, if you take mod of Z1 plus Z2 whole square plus mod of Z1 minus Z2 whole square is twice of mod of Z1 square plus mod of Z2 square. Take any example. Take any complex number. Say Z1 you take 1 plus root 3, I root 3. Z2 you take as 1 plus I, something like this. Suppose if question they ask you, what is Z1 plus Z2 mod square plus mod of Z1 minus Z2 square? What you have to do? 2 times mod of Z1. You take the mod of Z1, square it. That means no root. There is no root. 1 plus 3 plus. Similarly, take mod of Z2, square it without root. So what you'll get? 1 plus 1. So what it is? 4, 5, 6. 6 into 2, 12 will be the answer. Like this, all shortcut methods. A few formulas I have highlighted. You can do the remaining also. This formula is also interesting. Mod of Z power n is mod of Z power n. Like suppose if I give you Z is 1 plus I root 3. And I'll ask you mod of Z power 5. Then you need not multiply Z 5 times. What you take? Take the mod of Z. What it is? 1 plus 3 under square root. Take it power 5. Square root of 4 is 2. 2 power 5, that is 32 will be the answer. Now I may be a little fast. For some students, I may sound very fast. For some, I may sound very slow. But you have the recorded notes. Okay? You can go through it again and again. Slowly you can learn it again. The next is, for next formula, I'm pasting on the board. Properties of argument of Z. Argument means I'm telling about theta, angle of any complex number. Argument of any real number will be 0, positive real number. That means if I give you Z as 5, and if I ask you what is the angle of this Z, it will be 0. But argument of any negative real number will be pi. If I give you negative square root of 3, and if I ask you what is the angle of this complex number, it will be pi. Argument of Z minus Z bar will be plus or minus pi by 2. Argument of Z1 into Z2 will be argument of Z1 plus argument of Z2. Argument of Z1 by Z2 will be argument of Z1 minus argument of Z2. For this one example, I'll give you. Suppose Z1 I will give you cos pi by 3 plus I sin pi by 3. And Z2 I will give you cos pi by 4 plus I sin pi by 4. What is argument of Z1? What is the angle? Pi by 3. What is the argument of Z2? What is the angle? Pi by 4. So if someone asks you, what is the argument of Z1 into Z2? You can take argument of Z1, that is pi by 3. You can take argument of Z2, that is pi by 4. And you can add it up. So you will have 7 pi by 2. These two formulas are Argument of Z bar is same as minus argument of Z or argument of 1 over Z, 1 by Z. This also I will give you one example. This is also an interesting formula. So wherever it is interesting, take one example and I said you have to practice. Suppose if I say Z is 1 minus I root 3. And if I ask you find the argument of Z bar, then what you have to do? First of all, this you have to write it in mod amp form. How will you write it in mod amp form? Mod is 2. What is the angle? Angle X is positive and Y is negative. X positive, Y negative in the 4th quadrant. It happens in the 4th quadrant. 4th quadrant means 2 pi minus pi by 3. So it is 5 pi by 3. Cos 5 pi by 3 plus I sine 5 pi by 3. This is what you have. You must learn how to change it into mod amp form. Okay, I'll show you. I'll show you this, how to change it into mod amp form. Even though we are in a hurry, we have to go fast. Still, we have 4 days. Don't worry. 1 day for formulas of complex numbers, 1 day for problems on complex numbers, 1 day formulas of quadratic equations, 1 day problems on quadratic equations. While telling you formula itself, I am doing some problems. That's why you should not worry. So first, mod of Z you have to find. That is R you are finding. It will be square root of 1 plus 3, square root of 4, that is 2. Then amplitude, tan theta, B by A minus root 3. I'm finding minus root 3 for tan theta. Tan theta minus root 3. And one more thing you have to see here, X is positive, Y is negative, quadrants. See the X coordinate and Y coordinate. 1 comma minus root 3. It is in 4th quadrant because X is positive here, 4th quadrant. X is positive, Y is negative here. That means the angle should be in 4th quadrant. We know tan 60 is root 3. We know it is tan 60. But 4th quadrant means from 2 pi, you have to subtract 60. From 2 pi, you have to subtract 60. That is, you will get 5 pi by 3. That is how I got theta as 5 pi by 3. And so Z, that is 1 minus I root 3. I wrote it as mod is 2 and cos theta plus I sine theta. R into cos theta plus I sine theta. So the argument of Z is 5 pi by 3. Now, if I ask you, what is the argument of Z bar? We were learning this formula actually. What is argument of Z bar? It will be minus argument of Z. Negative. The argument of Z is 5 pi by 3. So negative pi by minus 5 pi using the formula. Okay, another interesting argument of Z plus argument of Z bar will be 0. Just now we did. Argument of Z is 5 pi by 3. Argument of Z bar is minus 5 by 3. If you add up both, you will get 0. They will cancel and you will get 0. Then polar form, already I told you, polar form is nothing but mod amp form. Both are same. Polar form, mod amp. Then one more important thing, Cos theta plus I sin theta can be written as cis theta, or it can be written as e power I theta. That is the form of writing, cos theta plus I sin theta. Then you have some important properties with omega. W is omega. You call it as omega. So omega cube is 1. 1 plus omega square is 0. These two are the formulas with omega. And what is omega? What is omega square? These you have to learn as formulas. Then there are some shortcut formulas, some more shortcut formulas, which I am going to give. With that, we will end with these formulas. If I give you these shortcut formulas, for shortcut formulas, there is no explanation. Remember that. You can't ask why it is. How did I get it? Those you can't ask. Because till now, whatever formulas I gave you, for that there was a proof. That's why I have proved it and I have shown to you many things. But shortcut formulas, there is no proof. These all are shortcut formulas. Whether I read or you read by yourself, it is one and the same, just reading them. But as I told you, if you want to by heart them, then you have to take some examples and do. At present, I'm just putting the formulas on the board. Let me first put all the shortcut formulas. And if the time permits, I will read. If the time doesn't permit, then you can read these formulas by yourself. Is this speed enough for you, or am I going fast? Hello? Hello, can anyone mute and answer my question? Is this speed enough for you, or am I going fast? What happened? No one is replying. You can unmute yourself. Anyone at least, you did not chat also. You did not put any message also. Either you put the message or reply. What happened? Are you there? Are you sleeping? Hello? I'm not hearing you. So these are the shortcut formulas which I have put them on the board, which will be asked in the questions. Z is cos theta plus I sin theta. Z Z plus 1 by Z will be 2 cos theta. Z minus 1 by Z will be 2i sin theta. Z power n plus 1 by Z power n will be 2 cos n theta. How they will ask you in the questions, I will tell you. Z, they will give you cos 2 pi by 3 plus I sin 2 pi by 3. Then they will ask you, what is Z cube plus 1 by Z cube? Then what you have to write? 2 cos the power n 3 into theta, that is 2 pi by 3. So 3 and 3 cancels. 3 cos 2 pi. Cos 2 pi is 1. So 2. 2 will be the answer. Otherwise, if you don't know this shortcut method, you have to first take Z, cube, multiply 3 times, take 1 by Z, multiply 3 times, then add them. Long procedure. See, while telling only, it is taking long procedure. When you use this shortcut method, very easy. Similarly, next, X is given as, oh, we don't have time, we have to end the class. Go through each of these shortcut formulas, take some examples and apply on them. From textbook, you can take any complex number, apply on it, and learn the formulas which I told you. Tomorrow, many times I'll be using this shortcut formulas, I'll mention. See you tomorrow.